Welcome to the Explainer. Today we are going to dig deep, and I mean literally dig deep, into the most important part of any building, the part you never even see, the foundation.
All right, so let's just kick things off with a question for you. When you're staring up at some massive skyscraper, or hey, even just looking at your own house, what do you think is the single most important part? Is it the shiny steel frame? The walls? Maybe the roof?
Well, you know what? For pretty much any building, the answer is the part you can't see at all. Nope, it's not the fancy glass exterior or how tall it is. It's the foundation, buried way down in the ground, silently doing all the heavy lifting.
So what's actually holding everything up? I mean, what is a foundation really doing down there? It's basically in this constant, invisible battle against some truly incredible forces. Think about it. A skyscraper like the Burj Khalifa weighs something like 500,000 tons. All of that weight, every single bit of it, has to be safely transferred into the ground. Let's break down what it's really up against.
Okay, so here's the official definition, but a better way to think about it is like this. The foundation is the crucial handshake between the building and the earth. It has one job, and one job only. Take all the loads, all the forces pushing and pulling on that structure, and spread them out so the ground below can actually take the strain without just giving up.
And it's not just one type of force either. A foundation is juggling 3 different kinds of loads all at once. You've got your dead loads. That's just the raw weight of the building itself. The concrete, the steel, you name it. Then you've got live loads. That's us, people, furniture, all the stuff that moves around inside. And then the big one, lateral loads. These are forces hitting it from the side, like wind pushing on a skyscraper, or the shaking from an earthquake. The foundation has to handle all of that all the time.
All right, let's talk about the ground beneath your feet. Because here's the catch. A foundation, no matter how well designed, is only as good as the ground it's sitting on. So before a single shovel hits the dirt, you absolutely have to know what you're dealing with, because not all soil is the same, not even close.
And when we talk about soil, we're mostly talking about 2 big families, sand and clay. And man, are they different. They're basically complete opposites. Sand is made of coarse grains, it doesn't stick together, and water just zips right through it. Put a load on it, and it settles pretty much instantly. Clay, on the other hand, it's fine-grained, super sticky, and it loves to hold on to water. This means it swells up when it's wet and shrinks when it's dry. And get this, it can take months, sometimes even years, to fully settle under a load. You can see why that's a nightmare for engineers.
So this is exactly why engineers do what's called a site investigation. They have to figure out the soil's safe bearing capacity. It's basically a measure of how much pressure the ground can take before it fails. And just look at the difference here. Dense gravel can handle a massive amount of weight. But look down at loose sand, way, way less. We're talking a huge difference in strength. Getting this number wrong isn't just a small mistake, it's a recipe for disaster.
Okay, so you know the forces coming down from the building, and you know what the ground can handle. Now, it's time to choose your foundation. Engineers have a whole toolbox of options, and they've got to pick the perfect one for the job.
And really, it all boils down to 2 main families: shallow foundations and deep foundations. It's pretty simple, actually. If the soil near the surface is good and strong, you can use a shallow foundation. But if that top layer is weak or unstable, well, then you got to dig deep. You have to bypass all that bad stuff to find a solid layer to rest on. Let's pop open that shallow foundation toolbox. First up, you've got your strip foundation. It's just a continuous concrete strip that runs under the walls. The analogy here is perfect. It's like wearing snowshoes to spread your weight so you don't sink. Then you have pad foundations. These are just isolated concrete pads that sit under individual columns. Simple, right? And for when the soil is really weak, you might go for a raft foundation. This is a huge, single slab of concrete under the entire building. It literally lets the building float on the weak ground, just like a raft on water. But what happens if that weak soil goes down and down and down? Well, that's when you call in the heavy hitters, deep foundations. We're talking about piles. Piles are basically giant stilts for your building. They're long columns that get driven or drilled way down into the earth, punching right through all the weak, mushy soil until they hit solid rock or a really strong layer of ground deep, deep below.
So we've gone from the blueprints to concrete. Because look, picking the right foundation is only half the battle. Now you actually have to build it. And this part requires absolute, total precision. You can't just wing it. There's a strict sequence of steps you have to follow to the letter.
Let's take a simple strip foundation as an example. First, you set out. You're basically drawing the lines on the ground. Then you excavate. You dig the trenches.
Now, step 3 is super important. An expert has to come in and inspect the soil at the bottom of that trench to make sure it's exactly what they thought it was. You can't skip this step. And finally, you pour the concrete, usually all in one go, to make one solid continuous structure.
Okay, so why does getting it right matter so much? I mean, why are we so obsessed with this? Because a tiny mistake down in the dirt can cause a total disaster up above. We're not talking about a little crack here or there. We're talking about something that could compromise the entire safety and life of the building.
And when a foundation does start to fail, believe me, the building will tell you. It leaves clues everywhere. You start seeing those classic diagonal cracks spreading out from the corners of doors and windows. You'll notice doors and windows start to stick or they just won't close right anymore. Maybe the floors start to feel uneven. These aren't just little quirks of an old house. They're warning signs, blinking red lights that something is seriously wrong underneath.
You know, a huge part of good foundation design is just about controlling water. And a key piece of that puzzle is something called the damp-proof course. Its whole job is to stop moisture from the ground from literally climbing up into the walls of the building. And there's a golden rule. It has to be at least 150 millimeters. That's about 6 inches above the ground. It seems like such a small detail, but getting it wrong can cause enormous problems.
And really, it all comes down to this quote, which says it all. A beautiful building on poor foundations is a disaster waiting to happen. A modest building on excellent foundations will stand for generations. Think about that. The most stunning piece of architecture is nothing without a solid base. The real story, the real strength of a building, it's all happening underground.
So let me leave you with this question. The next time you walk into a building, any building, are you going to think about what's holding it all up? Hopefully, now you'll have a whole new appreciation for that incredible hidden world of engineering that's happening right under your feet, silently keeping everything standing. I guarantee you'll never look at a building the same way again.